Okay, so on the next problem, we're going to look at a rotation around the y-axis. The work is exactly the same. You just have to remember you're looking for a slab of some sort, and you're going to want its thickness, and you're going to want its radius. And the formula is always going to be pi r squared h. It's just a matter of what we fill in for r and h. Pi can go inside the integral or outside. It's just easier to keep it on the outside when you're working with the calculator, or I think algebraically when you're working with it. And this is true for any rotated curve. You see rotation, this is the formula you're going to. So the curve we're going to rotate is going to be the curve y equals 4 minus x squared. And we're going to rotate that around the y-axis. So if I were to graph that, I know what that looks like. It looks like a half a parabola, because that's what it is. It looks like so. And we're looking at what's in the first quadrant, so it starts at 0. And the question is, how high up does it go? Well, in this span, when x is 0, y is 4. And how far out does it go? When y is 0, x is 2. So those, you can find that from the graph, but those are the numbers that are on there. When I rotate it around the axis, it's going to form an upside down, almost like the stem of a wine glass. And I'm going to make one slice on my curve right here. Not a bad slice, not the world's greatest slice, but which direction did I slice? I sliced in the y direction, so I got little bits of y. And then there's my radius. If my little bits are dy, I know my radius is going to be x. They're always going to be opposite of each other. And I can set up my integral. My integral goes from 0 to where? Well, because I'm going in the y direction, I'm starting down here and going up. My integral is going to go between 0 and 4 of x squared dy with pi on the outside. So I now have my integral set up correctly, but here we have the derivatives are in terms of y, and I have an x inside the parentheses. Inside the integral. I've got to get that x in terms of y. Do I have a relationship between x and y? Yes, I do. My relationship is y equals 4 minus x squared. But I need to know, I'm going to do this in two different approaches here. I need to know what either x, or, because the equation already has x squared in it, what x squared is. So I'm going to subtract 4 from each side. I get y minus 4 equals negative x squared. I'm just doing this twice to demonstrate something. You don't have to do it twice. Once is just fine. I've got negative x squared by itself. I'll multiply both sides by negative 1. And I get negative y plus 4 equals x squared. And over here I get negative y plus 4 equals x squared. There should be a minus sign there. I don't know where it went. And this one I've gotten down to x squared. If I wanted to get x by itself on this one right here, I could just square root both sides. And I'll get the square root of negative y plus 4 equals x. Now I can use either piece of information to fill back into there. If I put this piece in, I'm putting it in and I'm squaring it. So it becomes a square root of negative y plus 4 squared. And those suckers cancel each other out, and you just end up with negative y plus 4. This trick happens all the time with these y rotations. You just have to find x squared if you can. It often makes life easier. So I'm going to substitute this in for x squared, but I'm going to do it on another page. And I will put down pi, the integral, from 0 to 4 of negative y plus 4 dy. And this is a typical non-calculator problem. I'm now ready to integrate. I've got pi. The integral of negative y is negative y squared times 1/2 plus 4y. And I'm going to integrate that from 0 to 4. Many of you are looking at that 0 already and saying, well, that's not going to add anything onto the problem. I agree. I'm going to work it out just in case. Or Justin Bieber, either one. So I'm starting with my pi. I'm going to fill in my upper minus lower to begin with. I'm going to make a whole other set of parentheses. Negative 1/2 4 squared plus 4 times 4, close parentheses, minus negative 1/2 0 squared plus 4 times 0. Close parentheses. You don't have to use all these magic colors like I am, but hey, sometimes it helps to see what's going on. And I'll work out each section individually. Well, I know what this is going to be. That's going to be 0 minus pi there. What am I going to be left with over here? Well, I'm making one mistake. I should be carrying equal signs this whole way. Equals. So 4 squared is 16. 16 times negative 1/2 is negative 8, keeping my parentheses. 4 plus 4, 4 times 4 is 16. This is equal to pi times 8 minus 0, which is equal to 8 pi, an acceptable answer. I'm going to multiply the pi in. It's a little more than 3, so 8 times 3 is 24. So I'd say it's somewhere around 25, just to guess on the problem right there. You can always use this technique for solving the problem. I'm going to show you an alternate method here. Some people like this one better, and I'm fine if you do. If you start with the problem, y equals 4 minus x squared around the y-axis, and you change everything about the problem. You switch all the x's and y's, you can then rework the problem with that information. So this equation becomes x equals 4 minus y squared, and we're going to rotate around the x-axis. So the first thing I need to do is graph this, but I can't graph this unless y is by itself. So I'm doing the same steps, I'm just doing it at a different point in time. So I'll subtract 4 from each side. X minus 4 equals negative y squared. Multiply by negative 1. Y squared equals negative x plus 4. And to get y by itself, square rooting both sides, y equals square root of negative x plus 4. So if I go ahead and graph that on an axis, this is what I'm going to end up with. I'm going to end up with a shape that looks just like this. I'm going to rotate it around the x-axis. I need to know where this point is, though. You can see it from the graph if you wanted to, but on that graph, that's when y, we know y is 0 right here, because it doesn't have any height off the graph. At that point, y is 0. Well, where on the graph is y equal to 0? If I just fill in y equals 0, 0 equals square root of negative x plus 4. What would x have to be? X would have to be equal to 4 on the graph. That's what makes y equal to 0, so that point is 4. Now I'm rotating around the x-axis. I'm making one slice. It's dx. My height is y. So it's going to be the integral from 0 to 4 of y squared dx, with a pi on the outside. And I've got to get everything in terms of x, so it becomes pi, the integral, from 0 to 4, and in parentheses, square root of negative x plus 4, close parentheses, squared, dx. And if I could put that in the calculator just like that and get an answer, but that squared cancels out that radical, and you get pi, the integral, from 0 to 4, negative x plus 4, dx. And what you will notice is that equation is exactly the same, just with different letters, as the equation we got right here. So once again, solving it can be done either way. If you want to change it first, we're good to go. And then you always have to remember it's just upper minus lower when you have one curve.